Okay, in part one, we talked about the first derivative test, basically saying that if f prime of x changes from decreasing to increasing, then that means it's relative minimum. If it changes from increasing to decreasing, that's an example of a relative maximum. And if it doesn't change and these are at the critical points. If it doesn't change at a critical point from either, if it stays positive on both ends like you see here, or if it stays negative like you see here, those are examples of where you have no relative minimum or relative maximum at those critical points. All right, now let's look at a few examples. I went ahead and did these for you because of time. I didn't have to spend all my time going through them, so but I will explain how it goes through, and you can pause this anytime you need to, of course. All right, let's determine the relative extrema of the function f of x equals 1/2 x minus sine of x on the interval from 0 to 2 pi. All right. Now, first of all, f prime of x is going to be 1/2 minus cosine of x, and we set that equal to 0. We get 1/2 equals cosine of x, so our x values are at pi over 3 and 5 pi over 3. And you can check that from your unit circle. All right, now this is what the curve looks like. Now, we know it's going to be at pi over 3 and 5 pi over 3. You can see it from the graph here, but let's look at the data. So our interval's from 0 to pi over 3, and then from pi over 3 to 5 pi over 3, and then finally from 5 pi over 3 to 2 pi. So those are our three intervals. We have two critical numbers, so we should have three intervals. And we chose a test value, something that's between 0 and pi over 2. I chose pi over 4. You can choose pi over 6. You can use anything you want. I just happen to choose pi over 4. All right, so, and then I chose from pi over 3 to 5 pi over 3. And I just chose an easy one. I chose pi. It's right there. And then 5 pi over 3 to 2 pi. I chose 7 pi over 4. And then when I plug in those test values, so f prime of pi over 4 is a negative number. It's less than 0. So when you do that, that means it's a decreasing function. Well, if I do the same thing for pi, f prime of pi, that's positive. So that's going to mean it's going to be an increasing function. And then finally, f prime of 7 pi over 4 is less than 0. It is negative, so that means at that point it's decreasing. So what are we looking for? Well, we're looking for where it changes from decreasing to increasing. Since it does that right here, then that means at pi over 3, then that means that, and I should say x equals pi over 3, so let me rewrite that. At x equals pi over 3, you have a relative min, since it goes from decreasing to increasing. So that's a relative minimum. On the other hand, at x equals 5 pi over 3, that is considered a relative maximum because it goes from increasing to decreasing. Since it goes from increasing to decreasing, that means it is a relative maximum. So right there, relative maximum, and right here is a relative minimum. So a lot of work, but a simple test to determine whether or not the function is increasing or decreasing. All right, let me save this real quick. And let's do a couple more. Got two more for you. All right. For the given function, f of x equals 2x squared minus 4 to all to the 2/3, if I derive it through all the algebra, I'm going to get 2/3 times x squared minus 4 to the negative 1/3 times 2x. Remember, the derivative of what's inside is 2x. So when I simplify that, I get 4x all over 3 times x squared minus 4 to the 1/3, which when I factor this out, right here, it's going to give me x squared, x minus 2, x plus 2, which is where I get x equals 2 and x equals negative 2. And then up on top, because it's 4x, that gives me my 0 value. So now I have three critical numbers, which means I have four intervals. And since I have four intervals, It's going to go from negative infinity to negative 2, from negative 2 to 0, from 0 to 2, and then finally from 2 to positive infinity. So I just choose any numbers within those. I chose simple. I chose negative 3. I chose negative 1. I chose 0. And I chose positive 3. You don't have to choose the same ones. Just choose something that you can work with easily. All right. So now, when I plug in negative 3 into f prime, it's going to be negative. So it's decreasing. When I plug negative 1 into f prime, it's positive. So it's increasing. When I plug in f prime into 1, or 1 into f prime, it's negative, so it's decreasing. And then when I plug in 3 into f prime, it's going to be positive, so therefore it's increasing. And you can verify this by looking at the graph. See, it's decreasing, increasing, decreasing, and increasing again. You can verify that by looking at the graph. Always check it. If the graph is not given, graph it on your calculator. See what it does. Give a visual for yourself. Help yourself see it better. So, well, since it goes from decreasing to increasing, we have a relative minimum right there. And we also have a relative minimum right here. And that's evident at these 2 points right there. You can see them on the graph. Then you have a relative maximum right there, which is evident right there. So, you could, by determining whether they're increasing or decreasing and increasing, you could determine where the relative minimums are or where the relative maximums are. Okay, now let's do one more here. So here's the next one. This is the last one. It's kind of a long one, but that's why I'm spending some time. That's why I went ahead and wrote it out beforehand, so that way I'm not taking the time to write it out. All right, saving you some video time. Okay, f of x equals x to the fourth plus 1 all over x squared. Well, that can be written as x squared plus x to the negative second. And then when you derive that, you're going to end up with x or 2x minus 2x to the negative third, which that could be written as 2x to the fourth minus 2 all over x to the third, which factors the 2 out. I'm just doing the algebra here. You can look at the algebra. You can check it out on your own. But 2 times x to the fourth minus 1. Well, x to the fourth minus 1 factors to x squared plus 1, x squared minus 1. And x squared minus 1 factors to x plus 1, x minus 1, as you see right there. And then x squared plus 1, there you go. And then you have x to the third, which this gives you a critical number of, right there, right here, and right there. I hate orange. I just don't like the color. I mean, some of you like orange. I'm glad for you. I don't. So that's just me. All right. Now, so, and I'm just going to go highlight these again. -1 and +1. There we go. All right. So I use the interval from -1 to negative infinity to -1. I chose -2 as my test value. From -1 to 0, I chose -1/2 as my test value. And once again, you can choose anything you want in between there. I just chose those. But try to make it simple for yourself. That's all my only suggestion. From 0 to 1, you got 1/2. And then from 1 to infinity, you got +2. So then I do f prime. It is negative, so it's decreasing. F prime at -1/2 is positive, so it's increasing. F prime of 1/2 is negative, so it's decreasing. And then finally, f prime of 2 is positive, so therefore it is increasing. So here you go. Now, the last thing I want to show you, you have two relative minimum, and you can see that right here, and you can see that right there. Now, you'll also notice it goes from increasing to decreasing, but if you look at the graph, it goes to infinity in both directions. So really there is no minimum. Or sorry, there is no maximum here. So you got to verify by looking at the graph, because even though the data is right here, it's always good to take a moment and have the visual. All right, so that is increasing and decreasing functions. So for right now, make sure you know your derivatives and make sure you start working on WebAssign 3.3 for this Friday. Good luck.